already done and what we're going to do now in these video notes for the geometric sequences. For a definition, it's a set of numbers found by, instead of adding, multiplying. So before we had a common difference, now that same value is a common ratio. So just like before, we're going from the previous term to the next term. So if we look at our two examples we have here, you go from 2 to 6, and then 6 to 18, and 18 to 54. We're multiplying by 3. Our common ratio is 3. Next one's a little different because we're going 5 to negative 10 to positive 20. So we're actually multiplying by negative 2. So you can get those situations where you have alternating. Our connections, just like before, we have a domain that's a set of positive integers. Meaning it starts from 1 and goes on. Instead of linear like arithmetic, this graph is exponential. But remember, points are not connected. Okay, the notation's very similar to before. We have A1 and A2, first and second term. So again, that's the same. N is the term number. But instead of D, we have R for common ratio. With the intro, we already saw the formula. So we have the recursive A1 is equal to a number. AN is going to be the ratio times the previous term. And when you're filling the stuff in the formula, we're always filling in the R value and the A1 value. Now, I didn't do this with the previous recursive formulas. There's another option for writing the recursive formula. So an minus 1 meant our previous term. Another way to write it is to write the next term, which would be n plus 1. And then you would just use an in the formula. That's a little different looking. You'll see that a little bit more sometimes on standardized tests. So I just wanted to throw that in there in case you see that format of it. And when we go through different problems and reviews, that may show up for generating a sequence. The explicit formula, which you would use to find a term value, is going to be sometimes they'll use parentheses around the ratio or the R. Sometimes they won't. Depends on what it is. But it'll be the first term times R to the exponent of n minus 1, since this is exponential. So we'll just do a couple examples, and then we'll save the second video for the rest of the examples. Okay, this just asks you to rate the first 4 terms. So if we're starting with a1 equals 3 and r equals 4, another way we could say that, we could give you the recursive. Given that, generate the sequence. So it'd be 3, 12, 48, 192. It includes the first term that we already have, so you just had to find 3 other ones. Find the common ratio for the sequence. When you do this, you want to do the second term divided by the first term. I'd always simplify it, so this is going to end up being 1/2. Even though it looks like dividing by 2, we always want to talk about what we're multiplying by. 3, our common ratio is 2, because 3 times 2 is 6, 6 times 2 is 12. And then it also asks for the next 3 terms. So again, we're going to figure that out. After 24, 48, 96, 192. These will get a little repetitive, so the next one we're multiplying by 3. Again, if you're not sure, take 15 divided by 5, that is 3. 45 divided by 15, that is 3. Next 3 terms. So what you'll notice about a geometric is these sequences get large very quickly. The good news for you is that it means I'm not going to ask you to find a very high term. So there is potential for writing it out rather than using the formula. Okay, the next one's a little trickier to figure out, but if we do our second divided by our first, it does have a radical. If you simplify that, the 5's cancel, so you end up getting a common ratio of root 2. Now, every other term is going to work out nicely. So if I multiply 10 root 2 times root 2 for the next one, that's going to come out to 20. And you could use your calculator for this a little bit. The next time, if we do 20 times root 2, it's just going to be 20 root 2. And then again, if we take that and multiply by root 2, we're going to bump up to the next number, which will be 40. All right, last one on this page, and then we'll save the rest for the other video. So again, this one we're looking for our first term common ratio, and then coming up with a recursive and an explicit rule for that sequence. Our first term is 0.5. Now you can always do the second to the first, or you could do the third to the second. It's easier to see it if you do 8 divided by -2. That gives you -4 for your ratio. So for recursive, always remember to write your first term. And then your second part is -4, in this case, times the previous term. I'm just going to write an or. just so you get used to seeing those two different alternative options. And then for explicit, first term times the common ratio to the n minus 1. Notice I put the ratio in parentheses because it was negative. So usually with negatives and fractions, I put it in parentheses. You could always put it in parentheses. It assumes there's multiplying in between there. And then our next examples, we're actually going to use the formulas to solve for some values. That will be in your next video.